So the equation right here might have some parts to it that seem familiar. Notice it has the PV and the RT in it. Well, if you take the PV equals nRT equation, and if you combine it with molar mass, remember that's grams per mole. So if we're going to use little letters for those, grams is a mass and moles are in. I'm going to erase that middle section here. If you combine those two, where you're substituting in that N for that one, you will come up with this equation. And the reason that it's useful is because right here, this is a way to use information. Like, let's say you have a gas cylinder and you know that you know the size of it, it's got a gauge on it so you can tell the pressure in it. Let's say you know the cylinder before, like an empty cylinder mass, and you know you can tell how much gas is in it. You know the constant, and you can measure the temperature just by measuring the temperature of the room. You can figure out the identity of an unknown gas. So again, like, not like you want canisters just lying around. And you do have to make sure that the cylinder itself has the blank mass of just the cylinder, which several of them do. Then you can actually figure out the unknown by figuring out the molar mass. And then you would look at a periodic chart and you would figure out what that unknown gas was. So we've got an example here to explain. So what is the molar mass? Again, we're solving for the big M. If 1.008 grams occupies that much at that temperature and that pressure. Now, because this is like the PV equals nRT equation, this equation is very particular about how you put units in. So we're going to make our little list off to the side. Remember our pressure here. If you zoom in, I like to make a little notes to myself. The pressure here needs to be ATMs. The volume here needs to be a liter. The temperature here needs to be a Kelvin, R. And M needs to be a gram. And then this will come out to be grams per mole. All right, so those are the units. You have to have them in the right units. So we'll make our little list off to the side. So P is, let's see, we're looking for the millimeters of mercury, 743.1 millimeters of mercury. And then again, remember, I'm going to go ahead and just put my conversion in there so that I have it already written out and I don't forget to do it. V, and I'm going to look, there it is, 296 milliliters. And again, I'm going to write in my conversion. You can do 1,000 milliliters in 1 liter if you like, or you can do 1 times 10 to the minus third liters in 1 milliliter. Let's see, now this equation doesn't have an in it, so I don't need the N. I do have a mass. It's right here, and that one's all nice and normal. It's in the unit it's supposed to be. Let's see what else. We already know R, 0.0821. This is still liters, ATM, mole, Kelvin. And then T in, it needs to be in Kelvin. So 48 plus 273.15, that's going to give me my Kelvin unit. So we've got it filled in for this equation over here to the right. You'll notice that I have a mass right there. So that's my M. I have an R. That's my R right there. I have a V. It's over here. Now notice I went ahead and did that part of my head. Don't let that freak you out. I just did it in the head. Over here we have our P unit. And then lastly we have our T unit. Just sticking that whole thing in. And when you put that whole amount in your calculator, you're going to get this number over here. Don't forget, if you are going to just do 1 divided by a sign, you're going to need this whole thing in parentheses like that. You actually don't have to have this internal parentheses. It's just there to help you see the separation. You do have to have that parentheses. So then you're like, how useful is this? Well, if you pull up a periodic chart, you're going to see that the only element that this matches with is krypton.